Hi, I'm Shani, and this is the video recording for the presentation of sentient risk ranking of road infra project using satellite imagery. And this is the phase three presentation of the overall implementation happened during this project. So I am currently on the GitHub repo of this entire project, and this is the README file we have created. This is a detailed overview of this project, the overall project structure, then how to install the dependencies and how to run the overall pipeline of the entire modules. Then comes the API and the front end, and there is a detailed documentation of this entire project as well. So yeah, let me go in the editor to show you the entire thing one by one. So the entry point of this entire project is SRC. This is the README, the same thing. And in this, there are multiple modules. I'll go through every one by one and show you what happening inside that. So we have got the first ingestion layer that was the POC of this project earlier, in which we have a lot of data sources. So first I'll go to the architecture diagram in order to make you understand this project better. So there are multiple data sources, external data sources, which we are using in this project. There are Sentinel and Sentinel-2. These are satellite data from European Space Agency. There is Landsat data for the thermal stress measurement, and then population sensex data. Then ERA5 is the climate data which we are using. We have got OSM data for roads and public infrastructure coordinates, and then night light data again from satellites. We are having a data ingestion layer for overall data ingestion in batch pool. Then we are storing the raw data, then we are having some pre-processing and transformation over that data. Then from that pre-processed data, we calculate monthly stress feature engineering, which we are doing to get the overall accumulative stress around the road and the public infra to in order to calculate the next steps and the build the entire data for the model training. Then there is a CNN encoder for capturing the features in the satellite images, and then with other external data combined with the imagery of satellites, we transfer this data to the temporal modeling, whether this is LSTM and TCN. So we have built two temporal models. The first one is LSTM, and then second one is TCN. And then based on that, we are having risk score and aggregation, and there is validation, and then API and serving layer. So this is the entire pipeline which we are having here. We have built this ingestion pipeline in which each file has their own classes and objects, which uh, which overall have this ingestion completed. Then after the ingestion layer, we have this pre-processing layer where we are calculating the monthly stress. Then we also validate raw data, whether each data is complete or not, whether all the sources are available or not. And then based on this pre-processing, we transfer this into the features. So in the feature, based on the all the pre-processed data, we then calculate and build the data for the next pipeline of the training. So in the training, there is a training module where we train the model. So the first baseline model is trained on the tabular data. We use random forest and gradient boosting algorithm for the baseline tabular machine learning. These are the machine learning algorithms. In order in these, the random forest regressor wins. And then there is a CNN temporal model training happening here. And this the model is trained and the TCN temporal wins here. And after this training, we have this evaluation module, We have got this evaluation module in which we evaluate the model. We have so basically we are using 5 year data from 2020 to 2024 for Bangalore, and we have a split of 20 to 23 for 20 to 22 for training, and 23 2023 data is used for evaluation, and then 2024 data for test. So this is a common basically, so merging the overall pass for, so this is a common module, and then there is an API module in which we have created all the API which loads the model and then serves the output to the front end. And then there is a inference layer also, which loads the entire model, and then it answers through the API to the front end. There is a front end module that's complete the overall SRC. I'll go through the data folder again. So in data we have the raw data. So every sources we have arranged this data very beautifully in order for like uh, year by year and month by month. So for every sources, you can see here the data sources are kind of labeled very nicely here. And then uh, these raw data are kind of pre-processed, and then we create some kind of packet for overall unified data, and then the results data are here for overall model training. And then there is detailed docs which we have created here. So I'll show you those things also. So this is the entire just a second. I'll open a new terminal, and then I'll I'll try to open the documentation as well, so we can see the entire documentation of this project. uh, Give me a second. Yeah, so we have got this documentation open. So this is the entire developer documentation, uh, which helps any new developer so understand the overall documentation. So we have got everything module by module covered here. There is entire thing how to run, how to edit, and how to ingest whatever, how to run the pipelines, and then all these things are basically documented very beautifully here. So even in future any new team member or any new developer join us, then there is a very high chance very he will be very his learning will be very smooth via this documentation. So yeah, this is the overall uh, project. We have got the trained model here. I'll quickly show you the training matrix. So in this we have trained two type of models, as I have already told you. So the baseline model, we have a temporal GB gradient boosting, and this temporal RF, which is random forest. In this the temporal best model is temporal RF, which is temporal is kind of time series, and random forest wins in the first tabular model. And then there is a CNN temporal matrix in which we have got CNN LSTM here, and then also CNN TCN. So these are the two type of deep learning model which we have trained, and the best model is CNN TCN. And these are the trained model. We have pushed entire models on the GitHub also, and I'll show you the overall UI. So here is the UI. This shows road count by risk level. So this is a plot which has been displayed here. and then top 12 riskiest road it shows in the Bangalore area, and then it's also showing a histogram which basically is risk by zone. So these are the based on the naming cultures of north, west, and northeast, southwest, southeast. And this average risk by road type, and then there is a OpenStreetMap which displays these red lines which are the riskiest zone in the Bangalore, and then we are having a table basically that shows the prioritized road for inspection. So any decision maker can use this table in order to inspect quickly, and then there is a some kind of help how to use this data. So yeah, this is the overall project which we have built so far, and in the phase through concludes this entire project very beautifully. We have created and completed the entire module by module pipeline, and the overall architecture builds this very beautifully. So uh, I'll wind up this presentation for now. Thank you.